So I joined Facebook 10 months ago. It was an interesting experience to interview there. I realized that, man, there are a lot of French people in AI at Facebook, okay? Including Alex, so we had to ask him to kind of leave Facebook so there wouldn't be too many speakers on Facebook here today. You know, I joined Facebook because, you know, I thought that it was a place where you could really have a lot of impact with AI. I've been in AI for 20 years, and I'd like to kind of tell you what we think of AI at Facebook, why we do it, why it matters, how we do it. My talk could have been AI for good and how to do good AI, okay? So I'll talk about, you know, what we do at Facebook. I'll tell you a little bit about the path, you know, the way we look at the progress of AI and what you could call the path to AGI. I'll tell you a little bit also about the platform, what we think is necessary to make that progress. And I'll finish talking a lot about, you know, how we think about doing AI responsibly. Now, why AI at Facebook? So if you go to the main Facebook app, or if you go to Instagram, what you see on the app is really determined by a sophisticated AI algorithm. Actually, it's using some what's called sparse neural network, deep learning, to determine if the content that you see is of interest to you. Now, that's true for ads, and it's true for news. So pretty much everything, including the revenue at Facebook, is driven by AI. Now, there's a lot of things that are a little bit more visible about AI at Facebook. One is we use AI really to protect the community. So there's a lot of things happening in AI in many countries, actually, happening on Facebook. In many countries, actually, Facebook is kind of synonymous to the internet, and lots of things happen in the internet. So we have a kind of difficult task to try to moderate what's happening on Facebook in these different countries. So we need to figure out if people are trying to create clickbait, if they're trying to create hateful content, if they're trying to bully other people, and we have to do that in hundreds of languages. The only way you can do that at scale is to use AI to determine or to flag that content and let reviewers after determine what action to take. We also use AI for more fun stuff on the platform. If you start asking recommendations to your friends, the system will use NLP to determine that this is, you know, you're asking for a recommendation and parse the comments to put them on a map. We also use AI to let people communicate around language barriers. Now there are hundreds and even thousands of languages used on the platform, and we allow people to communicate across more than 4,000 language pairs automatically on the platform. We also use AI to kind of define new experiences. So Alex, who was there before, developed some technology to do bots that allow actually companies to interact with their customer through messengers. We also use AI to generate content, like if you upload a video, the system is able to summarize that video automatically and extract a thumbnail automatically. Also, AI is actually at the core of the augmented reality and virtual reality experience. Really, the technology to make these things happen is based on a sophisticated AI algorithm, mainly around vision. We also use AI to make things more accessible. So if you have difficulty seeing, the system is able to actually describe images and videos to you using advanced computer vision algorithms. We also use AI to do some kind of interesting things where you can actually look at what people post and determine that they need help, for example, if they are suicidal, or if they need a blood donation. You can actually use the platform to match people who are willing to give blood and receive blood. Beyond even Facebook, we use AI today to do some experiments. We partnered recently with NYU to accelerate MRIs. So MRI today takes an hour. It's pretty tedious if you're a child, for example. If you try to do an MRI for a child, it's very much of a problem because they don't want to stay still for an hour. So we're trying to get that down to a few minutes using vision algorithm that can extrapolate so that you can take less slices during MRI and can extrapolate the missing slices. But ultimately, really what's important for AI, and the reason I joined Facebook, is we need to use AI to make sure that our products are optimized for you know, the benefit of their users. You know, it used to be for many apps on the web that people try to optimize time spent. You know, try to optimize the engagement of people on the platform. But now we're trying to determine more sophisticated algorithm that try to optimize the benefit that people get from the platform. You know, is the app making you more informed? Is it making you happier? Is it making you, you know, it does enhance your life? And we are trying to create a system that can measure that. This said, you can see that AI is used everywhere on the platform. And it's really important for us to get a much more sophisticated AI so that we can use it to determine what's happening on the platform. I mentioned, for example, things like hate speech or bullying. It's actually very, very difficult to determine the language and the subtlety of the language so that the algorithm can tell you that this is 100% accurately hate speech or bullying. So it's really in our interest to make sure that AI keeps improving. Let me give you some examples. So the first thing is AI is improving. 6 years ago, there was kind of a bit of a breakthrough in AI where people started to use deep learning for image recognition. So that's the task on the left here, where you can look at an image and determine what's in this image. The task called ImageNet, maybe you've heard about it during the past 2 days. And people show that using deep learning algorithm, you can get to a performance that nowadays is actually better than humans, and I'll tell you a little bit more about it in a minute. But over the past 6 years, we've actually really improved that algorithm. AI keeps making progress. So you can see that not only we're able to identify persons, but we're able to identify shapes more and more accurately, and even skeleton in the shapes. And in the past 2 years, we're able to do that not only through large computing servers, but we're able to do that in real time on a phone. And just today, we're able to not only identify the shapes and the skeleton, but you're actually able to identify the surface of the body in real time on a phone. Just as we say that AI is really making progress. Now, this progress actually has some interesting characteristics. So this is a plot that was created by OpenAI, and it shows what is the amount of compute used by the most, I would say, sophisticated experiment over the years. And you can see that the amount of compute is basically increasing at a 10x rate. So each year, the next experiment takes 10 times more resources than the previous one. Now, if you look at the upper right there, AlphaGo 0, I can tell you that this is an experiment where each run may cost you around a few $100,000 to a few $1 million. So the whole experiment actually will cost you potentially tens of millions of dollars. Now, the conclusion of this graph, according to OpenAI, is to say that, well, we will need a lot more compute in the future, and that's a key, really, battle for AI of the future. But actually, if you think about it, even with Moore's law, there's no way in a year or two we will start spending hundreds of millions of dollars or billions of dollars in an experiment. So what this tells us is that this race to compute is going to come to an end. And what that also tells us is that we need to find new methods for learning. Okay, we cannot just use brute force learning to make progress in AI. So I'll give you some example of the way we look at doing learning a bit differently, not through doing label data, not through labeling a lot of data, but sort of using the data that's out there to try to learn from it in a more intelligent way. The first example is what we call semi-supervised learning. So at Facebook, we have access to a lot of public data, and in this case, Instagram data, where people naturally will actually provide tags to the data. So I mentioned earlier the task of ImageNet, and we have shown earlier this year that by using the tags that people provide, rather than traditionally asking, like on Mechanical Turk, people to tag according to the ImageNet task, we were able to use all these tags, even if sometimes they were very inaccurate, to basically train a system to perform better on ImageNet. And the results were quite interesting. We were able to feed 3.5 billion images to the system and improve the state of the art at ImageNet, even though the tags that people provide may be inaccurate and may not reflect actually the class that are used for ImageNet. So again, this is an example of using kind of data in the wild rather than kind of brute force labeling approach to make some progress. Another interesting example, machine translation. So this year, we are able to do machine translation in an unsupervised way. If you are a little familiar with what's called supervised machine translation, normally the traditional way to do machine translation through a computer is to give it a lot of example of translation. So the original algorithm used the laws in Canada, where you have a lot of parallel text between French laws in French and in English, and you can use that text and look at the mapping between the words to train a system. Now, what we're able to do is give a computer a lot of French text and give it a lot of English text. Let it figure out kind of the structure. That's what this diagram is supposed to do, like kind of the structure, the semantic structure of the word space. And the system will look at the two word space and basically create a translation, a rotation between the two, a mapping. And by that, it's able to learn, actually, all the word-to-word translation between two languages without ever seeing a single example of translation. And we were able to show this year that for unusual languages, like, let's say, French to Urdu or English to Egyptian, you were able to get better than state-of-the-art using this method without ever giving a single example of translation. The last example I show is what we call self-supervised learning in the real world. So we're actually looking at using robots, and sometimes we actually put robots in homes to give it a more real-world feel. and you let the robot perform tasks. And the robot is able to determine that if it's successful on its own or not with that task. And using that feedback mechanism that it's able to determine by itself, you're able to train the system. So that's what's called self-supervised learning. And it's becoming more and more useful out there. We realize that if you use self-supervised learning, there's a lot of data out there where you can use part of the data to train based on the other side of the data. Another example of that is you can feed a system videos and ask it to predict the next frame of the video. Or you can feed it images and remove the color and ask the system to try to predict the colors. And by doing that, it can actually understand kind of have a representation of images or videos that's really refined. And here in this case, you basically give it a task in the while and you let the computer ignore one aspect and learn it, when is it able to grasp. So all this to say that we are really trying to go beyond the traditional approaches and get people to get systems that learn in a more natural way and more in the real world than what we are used to do. Facebook is, as I mentioned, one of the biggest consumer of AI today. And our interest is not necessarily for us or my team, I have a big team, but it's not necessarily for us to develop that AI, but it's for the world to improve in AI. Every improvement in AI out there basically serves us. If you can create a system that has better understanding of language, Facebook would like to benefit from that. So our view around AI is really to create an ecosystem of organization that can contribute to AI and benefit from each other. So our research team is really focused around open sourcing everything we do and collaborating with a lot of institutions out there. I just come back from Africa just this morning, where we launched actually a new master in machine learning. It's really important for us that the level of education and the level of proficiency of people in the world gets better because we believe we'll benefit from that. Now, what we also have done is try to really improve the rates of transfer from research to production. And recently this year, we actually combined our system internally. So at Facebook, you used to have a system for research, which was called PyTorch, and a system for production that was called Cafe 2, okay? And as I mentioned, it's really important for us that we can take the breakthrough technology and bring it to our production to help our systems. So we announced earlier this year something that's called PyTorch 1.0. The pre-release was delivered just 2 weeks ago, and it's really kind of a system that delivers a more user-centric paradigm to a deep learning framework. Not only we deliver PyTorch 1.0, but we are trying to create an ecosystem of open source technology around PyTorch. If you want the best system for vision, if you want the best system for language, if you want the best system for reasoning, we are trying to develop this system, put them on GitLab, on GitHub, and get other people to innovate on top of that and provide their own innovation. So we're a really big believer that we think that a good AI is an AI that's open and that everybody can use and benefit from and improve. My goal is really to make sure that many people can use AI as quickly and as easily as possible. But there's another aspect to that. As I've stated a goal at Facebook that I wanted to have 50% of our developers use AI day in, day out, and potentially 50% of developers in the world use PyTorch and our ecosystem around AI to develop new AI. But we cannot do that without providing to people the right tools so that they can do responsible AI. Let me give you some examples as to why, when you use AI, you can actually make some pretty far-reaching mistakes. Let's take a pretty, mundane example. At Facebook, we have we bought Oculus, and we're trying to develop what's called social VR. So we have a system that can take a picture of you and develop an avatar that looks like you. Now, it's a very interesting problem to try to do that in the right way. So, if I had to develop a system like this, I'm sure that I would never think that there are actually 13 types of different beards out there, okay? I don't have a beard, I never thought about it. And so when we have noticed that when people actually develop a system like this, they think of the attributes of the face that match more where they come from and the different attributes that they have. So we had to develop a system to make sure that as we develop all the potential attributes and as we feed data to the system, we are not injecting our own biases in the system, and it's representative of the whole population of the world. And this is an example of something that happens a lot in AI, where you basically have this interaction between people, data, and algorithm, right? So the evil part of the talk is that people have biases, right? And these biases basically will be transmitted to the data that's created, based on the task that people perform. And the problem is that algorithms learn from data. Machine learning algorithms are made to learn from data. And when you learn from data, you will actually, if you just don't pay attention, you will reproduce the biases that are in this data. And unfortunately, algorithm can run much faster than humans, so if you don't pay attention, you can just amplify the biases that are in the data. So, the social VR one, that's a cute example, but there are much more difficult examples out there. So this is an headline that came out just last week, I believe, which said that Amazon had developed a recruiting tool that shows some biases against women, okay? And let me show you how that can happen very, very easily. If you create a job system or a recruiting system, right, you will try to basically match people to job opportunities, right? So you have a lot of people out there, and you try to say, okay, which job is better for a given person, right? If you look at your data and the way you suggest these jobs, and if you look at the overall population, let's imagine that you divide it in different demographics, like over 40 and under 40, and female versus male, right? So the question there is, are you giving the same kind of jobs and proposing the same kind of jobs to all these different population, right? And as you do that, are you learning from the prior, which is the history of jobs, or are you trying to do that in a fair way, right? So we're trying to develop tools that actually measure the economic opportunity, in this case, that you're offering all the different candidates. But you can think, right, that very easily the system could reproduce the biases that happen historically. So if you think of, let's say, computer jobs, right? Well, today there are more computer jobs that are fulfilled by male, right? Does it mean that you should actually offer more computer jobs to male versus female, right? In the same way, Silicon Valley has a bit of a age problem today. There's a lot of young people who get more jobs. Should you actually, your system, reproduce that problem, right? Obviously, the answer is no. And you need to create a system that can measure if your system has bias, and in the case, highlight it, and help you basically measure and correct these biases, right? What is the best way to actually go about this? Let me actually give you an interesting anecdote. In my team, a woman called Joanne Pilot, and she told me the story that one day she was called to help design a speech recognition system for a helicopter cockpit, right? So she went to that team. The team there had already a system. She goes, tries that system, and it completely failed for her, right? Didn't recognize her voice, didn't work at all. The whole team tells her, no, our system is state-of-the-art, it works really well, right? Guess what she figured out? That basically they had trained the system and tested it only with male voices, right? And this is an interesting story because it shows that just having one person coming from a diverse background will actually immediately have an effect on having people think of creating systems that work for a diversity of people, right? If I can leave you with one idea today is that diversity matters, and one problem we have in AI today is that our systems have a lot of impact on society, and we need to make sure that the people actually developing these systems come from all parts of society and represent the diversity of the population in society, right? And the best way to create fair system is to have people who develop it who know what fairness is for themselves and can represent the whole society. I hope I show you today that at Facebook we really care about AI, that we have an interesting plan, looking at new techniques to develop AI that can learn faster and more real world. That we think actually about AI in a way that's very open. We want everybody to be able to develop AI. We want to benefit from the progress of AI. It's important for us that AI progress, but we also think that you need to do that responsibly. You need an AI that actually is fair and developed by people who represent the whole of society. Thank you.